Hi there, and welcome back. My name is Steven, and I'm here to teach you more about C#, .NET, and Windows. This episode, we're talking about C# debugging in Visual Studio. How do we handle errors will come in the next episode. This one is going to be all about figuring out where they are and kind of interpreting the error messages that come from Visual Studio and the interfaces that you see. We're going to start out with a couple of really basic things like what panes or tool windows you should see in Visual Studio that will help you out. We're going to talk about a couple of websites, the difference between semantic and syntax errors. We'll talk about mentality as well, because that's a big part of what goes into the debugging process. And ultimately, some of the cool tools that Visual Studio allows you to use to jump around in your code base. Let's jump right into what panes you should use. Pane number one is going to be output. Output during runtime is huge. This allows you to see what your program is doing on a regular basis, such as what values are being passed in. It allows you to see stack traces. It allows you to see error codes versus success codes, as well as a bunch of custom messages. I'll show you what I mean by custom messages here. If you remember from our last video, when we click on output values, we did this console.writeLine feature. This console.writeLine command writes out to this output console. Essentially what it does is it says, hey, the user, or the programmer rather, wants to see what's happening in this interaction. Let's put it on a screen, but don't let the user see it necessarily. It's a really useful and capable tool that allows us to view the back end of our code without actually seeing the code. It seems a little bit confusing, but we'll get into kind of what that's doing when we actually start debugging a program a little bit later. There's also another program feature called attach to process, and we'll talk about that as well. That's a really great feature that a lot of debuggers actually allow you to use. I think Java with IntelliJ, maybe PyCharm does as well. I'm not overly familiar with other IDEs because I've been in Visual Studio for so long, but attached to process allows you to take a running program that's written in the .NET framework, such as if we were to deploy our first application here, and put it out to or attach to that process. So while it's running and we notice there's an error that's reproducible, we can take Visual Studio, open up that code base that we have, attach it to that process, and view what the program is doing. It's really useful, and we'll do that during breakpoints or at the end of the video when we have a little bit of time to talk through that. That might be a little bit more wing it than the rest of the video, although most of my videos are pretty wing it mentality anyway. So the output window is extremely useful in helping you determine errors and issues at runtime with custom messages. You don't have to just send in a string value. You can actually send in an iterative value. So if we were to do, if we were to do int I equals 0, and we were to do our I++ here, we can actually output I. And when we hit our output values button, it'll show us our 1, 2, 3 instead. We can put in pretty much whatever we want to. I could put a button in there, and that's another great thing that we can cover as well in this, is how to get useful information. Because when I was first starting out and it didn't really click for me, I would pass in, say, a button variable. Just no joke, created a button called btn equals new button, and say the button.content, button.text, because I'm in Visual or Windows Forms, button.text equals save me. Say I wanted to get that button text out, I would accidentally put in, or I intentionally put in button, thinking that it would tell me all of the properties I needed to know about button. And it doesn't. Oh, it does. That is a new feature of Visual Studio. It will tell you the text of your button. That is cool. So when I first started C#, we were in Visual Studio 2013, I believe, was brand spanking new. It had just come out, and they didn't have that. It would just output Windows or system.windows.forms.button. I think WPF did that as well when I got into it. Now that we're moving forward and Microsoft says, oh, hey, that might be kind of useful to have. Man, we should really put something like that in there. They finally do, and finally did. And C# recently, fairly recently, a few years ago, I think, became an open source language. So you can actually view the source behind C# and the compiler therefore. Anyway, sorry, back at this. Let's talk about, because we have our console.write line, let's talk about the, oh, sorry about that. I forgot to give you a shortcut for this. This one is Control-W-O. The mentality behind the shortcuts for the tool windows that you'll see in Visual Studio often has a prefix, so to speak, kind of like you would find in English. If you are opening a window, you're going to use Control to control your interface, W for window, and whatever the first initial of the pane is usually. For Solution Explorer, as we discussed before, it's Control-WS. For tools, for toolbox, because T is already taken, they did Control-WX. For output window, it's Control-WO. And for our next one, which is our error window, it's going to be Control-WE. Error list. Error list is an incredibly useful one because it will show you syntactical errors as well as some implied potential errors and warnings. For instance, if I did bool thingy equals false, we get a warning. A warning is a message from Visual Studio that says, hey, this isn't going to break your program, but it's probably not a good thing that you have just some random value or some random variable taking up space in memory. It's not very conscious. So it's never used. The variable is assigned, but the value is never used. We can hop over across to a different window as well, and that error persists. It's not just contextual based on what file you have open. If you double click the warning or error, it will show up in your, or it'll show up on the line. Move your cursor to the line where the error or warning is. Oh, the other thing that you'll see is you'll see highlights on the side here. Now, bool thingy equals false is a warning. You'll see this little green spot here. That's usually a warning or an implied issue. Not necessarily a critical issue, but something you may want to address to make your program run a little bit cleaner. If I were to, say, forget to declare it, but I left my equals sign there, that's improper syntax. This is a syntax error. Syntax errors are where there's a typo or an issue with the command set that you've entered into the file that Visual Studio says, hey, the C# compiler is not going to understand what you're trying to do here. Something's wrong. You need to analyze and take a look at it. In this case, it's not a warning. It's not a yellow flag. This is a red X, or white X in a red circle. If I try to start my program with this, Microsoft Visual Studio says there were build errors. Would you like to continue and run the last successful build? I don't usually do this because I know that if it's not running now, there's no use in me testing a broken version in this case. It is nice that they offer the option because I could see a use case where I do want to go back to what it was, but in this case, I don't think that's very useful. We know that we have an error. Let's address it. So we're going to hit no here, and it's not going to compile. It's not going to try to proceed. If I hit start and I hit yes, it will open up my error list based on preferences. It'll open up the previous version. So I can still interact with this, but it's essentially omitting my errored line, my new line, and any new code that's been entered into the program between the previous successful build and the one I'm on now. On larger code bases, this is not a great way to handle source or to handle source control. You don't want to just compile all of the time, because that takes up a bunch of resources and time. Instead, you would rather just fix the errors more often than not. So again, we can double click our error. It'll move our cursor here, and it will show up in our code lens map on the side as thingy. I say code lens, but that's a proprietary third-party application or plugin for Visual Studio Code, which is a lighter weight scripting environment and programming environment that Microsoft has put out that is much more extensible and a lot cleaner for a lot of different kinds of file types. We can do a series on Visual Studio Code at some point, but Code Lens is a tool for that, and I just prefer the name of that over Peak View or something along those lines. So to resolve our errors, we just make sure that we give it a valid value, and that pretty much fixes syntax errors. Syntax errors have become, for the most part, fairly simple to troubleshoot and fix. The solutions are usually pretty straightforward. Not always, but quite often. They can also stem from, say, forgetting to put an access modifier in, and then declaring this as a public. That doesn't necessarily compile. So make sure that you're following the proper aspects of the classes generated by Visual Studio. If you have any questions so far, go ahead and right click on this video screen and copy the video link at the current time, throw it in the comments, and refer to that. If you have questions, or if you want to understand something a little bit better, you want me to go into detail, feel free to ask questions that way. It gives me an exact concrete area in the video where you had some questions, and I'd be able to address that a little bit more easily. Anyway, so now we've talked about syntactical errors or syntax errors. Let's talk about semantic errors. If you remember in my looping video, we went through and had a couple of issues because I forget my iterators a lot. So say we have actually, let's do something real simple. Let's do while and I equals 0 again, while I is less than 10, console.writeLine I. Valid loop. Great. So I'm going to hit start. I want to view my output, and I'm going to hit output values. Now, what do you think is going to happen here? I'll give you a second to think about it, and then let's actually try it. Good? Great. So what will actually happen, because I forgot a key part of this, forgot intentionally this time, we have what's known as an infinite loop. This is a semantic error. Eventually Visual Studio will freak out and break, and we're going to talk about breaking in this video actually, because we're going to talk about breakpoints again. I don't want Visual Studio to break. I know there's an error. Let's talk about breakpoints again. A little bit more in depth, maybe. It might just be a recap, but my computer's choking on it because it's an infinite loop. But breakpoints are going to be a key aspect that you use for debugging. There it is. Yeah, let's stop that now. If it'll do it. It might just crash Visual Studio. Infinite loops are bad. Bad, 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 bad. Try to avoid them at all costs. If you have a sketchy piece of code that you're not sure about, throw a breakpoint in there, which is a lovely segue. Not like the ones you ride on. So, breakpoints. The shortcut key to put a breakpoint on a specific line of code where your cursor is. Move your cursor to the line you want to, and you can hit F9. F9 will toggle a breakpoint on your current line of code where your cursor is. Your cursor determines what line you are on contextually for Visual Studio, and you can do a lot of things based on where your cursor position is in the program. F9 toggles a breakpoint on or off, and a breakpoint, as I've said before, is just a giant stop sign in your code that Visual Studio says, oh hey, pause everything, we're going to step through this, or step into, step out of, etc. We'll also break down what those commands are in just a second. Int I equals 0 is our declaration point. Basically, after we clear our list, I want to stop and I want to see what the heck my code is doing. So we're going to hit F5 to start our form again, and I'm going to hit output values. Now, I is not declared yet because we have stopped on that line. We have not declared I. The compiler has no idea that I exists, and therefore you can't see any values related to I'm proven wrong once again. Interesting. Well, you heard it here first. This video is a mess of just me talking out of my rear end. Okay, well, apparently the compiler does know I exists, but we're going to continue anyway. Sorry about that. I apparently am no expert. So if we want to continue to the next line, we can hit F10. F10 is technically step over. We talked about that in the last video as well. Step over, right? Make sure I'm not talking out of my rear end again. Yeah, step over is F10. Step over, if this were a method call or a function call, it would basically skip that entire method or function for review. If you know that a method or function works and you don't care about the inputs or how that method is working, you can step over that declaration of a variable because you already know that it's verified, it's already working. So rather than go through and have to mash F10 or F11, which is step into, all the time, you can just hit F10. It'll execute that function just fine and get you back to where you are rooted, where your next cursor would be. Let me show you that actually briefly. So if I had a method called private int get initial I value, we're going to, yeah, this is going to be a little bit weird, but we'll declare I up there instead. We'll throw our toggle point or our breakpoint there. We have a syntactical error because we are asking this function to return an int. We're going to get into methods and functions here in another video. But we have this integer that it's called the signature when it's in the declaration of the method. Again, we'll get into it. But essentially, when you hover over a syntactical error, Visual Studio will try to help you fix it. In this case, not all code paths return a value. That means that the method or function is not returning anything with the return keyword. In this case, we're going to say I++, I think. No, we're going to return 0 because why not? I equals get initial value, get initial I value. And let's run this. So to demonstrate, this is purely to demonstrate F10 versus F11. We're going to hit our output values, hit our breakpoint. F10 will skip forward a line because it's already done all this. I is equal to 0. You can right click on a line, by the way, and go to the I always have trouble finding it. Set next statement. Control Shift F10, and it will move your compiler back to the line that you want to most of the time. There's some contextual stuff that is important to understand. You'll see me use it when we get into more complex solutions. I don't really see a reason to cover it at this point. It's just going to make this video much longer. And I'll have another video later on that's my programmers or software engineers' everyday tools. I don't really have an everyday carry other than my phone, wallet, and keys, but I have an everyday tool set that I use for my coding stuff. And we'll go over that. If you want to see that, throw a like on the video or throw it in the comments. I greatly appreciate any kind of feedback that you can give me, whether or not it's a like or a follow or whatever, subscription, what have you. So in this case, I want to show you what F11 does, which is step into. So we have our cursor currently and our compiler currently on I equals get initial I value. And if I hit F11, it enters into that method get initial I value. We're stepping into that method and analyzing or stepping into the code that we want to. And then we can move forward a line with either F10 or F11, depending on how deep the rabbit hole of nested functions and methods get. That's where you have a method call here, and then that calls another method, and then that calls another method. It can get a little confusing, but it's done everywhere, and it kind of has to, because your program is going to be built on dependency. Each method and function is going to rely on data or functions that are declared elsewhere. In this case, we're moving line by line, and we don't have any methods in here, so F10, F11 doesn't matter. But if we wanted to search another method within the get initial I value, we could hit F11 to step into that as well, and it would eventually return us to this method here, this get initial I value. In this case, I'm hitting F10 because I don't care. Return is going to send 0 back to the I value because of our equivalent or our value set operator, and I is now equal to 0 because when we hit F11 and there's nowhere beyond our return statement, it's going to, or there's nowhere beyond return. That return is the last line that can be executed in a context or in a method and function, really. F11 will return us back to where our cursor was initially to show you that the variable is being set there, and then it will allow you to execute just the same with F10, F11. And you can mash F10, F11 if you're in a loop. So back to semantic errors. I know there's a rabbit hole there, but it's really important to have some visual aid for some of these concepts, and they play off of each other. Debugging is a complex and difficult thing to do, especially if you haven't had exposure to it. Let's stop our program here because there's nowhere else to go. Semantic errors from here are usually a lot more difficult to figure out solutions to. This is a really basic example, and I'm actually going to back out this function because it's going to overcomplicate this particular debugging process. If you're not familiar with Control X from pretty much any other program in Windows, Control X is cut, which basically deletes the line and copies it to your clipboard so you can paste it elsewhere. I use Control X to delete entire lines in Visual Studio quite a bit when I want to reorder and refactor where my code is. I use that one a lot instead of Control C, although I do use Control C a lot for copy. Control KD auto formats your document too. So if you see like a bunch of weird white spacing, like something like this, and you're not really sure where everything belongs, make sure that you check with your tech lead or your manager or your code lead, I guess. I don't know what other organizations would call that, but check with them to make sure that it's okay to do that, because if you're doing source control, it makes it really difficult to read source control or source control differentials. But you can use Control KD to auto format your indentations in your white space for the most part. If you have it somewhere close to where Visual Studio says the industry standard is, Control KD will automatically do that for you. There are some instances where it really doesn't work that well, and it can play around with your white spacing. For instance, if you have this all out of whack and you forget your semicolon, and then you try to do Control KD, the lines that follow the syntax error don't get formatted properly. All right, so by analyzing my logic through my step throughs and my step overs and my step intos, I can see that while is just not exiting. We're not breaking here. We are breaking, but we're not breaking out of the loop. So there are two ways that you can break out of a loop, and you can either do that by making this condition false, or you can type in a break keyword, which I think we covered a little bit in the conditionals episode. Break essentially takes your context, especially out of loops, and says, oh, hey, this is contextually within a loop, and we're done with all of the calculations within the loop. You can see when you highlight over break, it'll tell you which while statement or which loop statement it is contextually relevant to, and it will get you out of that loop. The better way to do this, though, would be make your statement false. Make the conditional for your loop statement false. That ensures that you are meeting the criteria necessary for your loop to be functional and operational in an expectant way. So now we're outputting our values. You could also see why it was a problem, or how it was a problem. I'm gonna hate that. Yeah, let's do a breakpoint here. You can also see it's a problem because if I just continue execution of the program, you can see zeros just constantly in the output console. That is because I is not incrementing at all. That's another way to think about it. Not only is it an infinite loop, but I is not incrementing. So when you put those two factors together, oh, hey, I forgot to increment I, therefore the while condition would never be met, and therefore would constantly just resurface through this loop. That syntax highlighting is another key component of your debugging process, because you can highlight or you can throw your cursor over top of curly braces, square brackets. Typically parentheses are a big one, especially if you have big long if statements and a bunch of or and conditional or operators in your conditionals and things like that. If you hover over, or if you place your cursor over specific curly brackets or your parentheses, it will actually show you where the sister component of your particular selection is. In this case, you can see that if I put my cursor before the opening curly bracket, it will show me my contextual closing curly bracket. If I put it before the parentheses, it'll show me the closing parentheses. If I put it after the closing component, in this case the closing parentheses, it will show me the sister component to that parentheses that opens the context. You can also see, like I said before, where break is relevant to the while loop, because, for instance, I may have a, say, O equaling 10, and maybe we go O minus minus, and then while O is greater than 0, we're going to decrement O, rather. Console.writeLine like that. That's an important use of your, that is an important use of your console.writeLine as well. You can just pass other values in for strings for useful error handling. We'll get into error handling in the next episode. In this case, I'm doing it simply to show which values are which, so that I is equal to something, O is equal to something. That way I don't just have to try to remember which order I and O are output to the console in. And if I want to do a break here, then it doesn't apply to the top while, even though it is contextually relevant to while. The immediate parent context is the nested while. In this case, you can see, because this while statement is indented from the while at line 44, you can see your line numbers here. Because it's indented from this while, visually and mentally, you can kind of lock that into your brain saying, oh, hey, this is inside of the while block. Whitespace is super important for ease of debugging and readability. Readability is super, super key. But that pretty much covers our breakpoints. There is one more pane that I want to show you. And I mean that like a window pane, although it isn't always. Let's see if we can do something like, trying to think of an example of how to get a stack trace. And the best I could probably say, or the easiest I could probably say, is if I do this isn't necessarily going to make sense because we haven't gone over IO stuff because it's fairly complex and jargony. We'll go over it because IO is imperative, but we're not going to go over it right now. To cover briefly what the @ symbol is doing here, this is going to be, to briefly cover what this @ symbol is, it's a string literal delimiter. Basically, it indicates that we don't want to escape, we don't want to treat these backslashes as escape characters. We haven't gone over regular expressions yet. Again, later video. What you need to know though is if I didn't have this, this would be a problem because it doesn't understand \t, which in regular expressions is a stand-in value for a tab. Like if I were to hit the tab key. So instead of having to go through and escape that, essentially make it a safe value, I prefer string literals, which say that the value that I'm passing into this is literally what I'm typing. Interpret it that way, and the compiler will go through and automatically escape those characters. You have to be careful with string literals to a degree because even though they're easier to read, there's some interplay that can be difficult with them if you're not careful. In this case, temporary file.txt does not exist on my system. If I really wanted to, I could really make it not exist to prove it. This is going to throw a stack trace problem because this file does not exist. Our read all text opens a text file, reads all lines of the file, and then closes the file. If the file doesn't exist and I don't handle that, we get an error. And this is what's known as an exception. An exception is a semantic error. Basically, my syntax is fine, but there's an unexpected value that the compiler ran into when it was trying to do an operation. So this exception text here is called the stack trace. In this case, the call stack. This is the information or the steps taken to get to a point where we broke. And you read it from the top down in order of the error occurred here on the top line, and back is the historical functions in time that were used to get to where you're at. Essentially, it's a reverse log or a reverse chronological log. So the exception was originally thrown at this call stack. The IO, input output, when we passed, or when an int or string was passed in, well, I don't recognize this. I don't know what that method is, so it's not relevant to my code specifically. File stream init, not mine. File stream reader. I'm starting to get an idea that it's a file read. And we only have one file read in our program. But, oh hey, file.readAllText, that looks familiar. We entered that in. First application.form.button values click. Hey, there's an event handler I know. That is that's when I click my output values button to output text to my console. That's in my form1 class that we're in here. On click, on mouse up. That stuff doesn't make sense. But I know that when I'm clicking the output button, I'm getting this call stack, and I also know that contained in there is this read all text. Well, read all text triggered all of these methods and functions that are necessary to do that read all from text function that's baked in functionality for the IO class and dependency. But I know read all text. So I can go back here and say, oh, hey, great. I know that this is breaking. Now, you're probably thinking, well, I've got this really handy exception unhandled pane that's popped up and given me this information. Why the heck would I go through all the process of reading that stack trace? Well, we'll cover more of it in exception handling when we get there, but you don't always have that pop-up. If you do a try-catch block around this stuff, it will mitigate that from popping up. It won't crash the program, but it will put that information in your console or allow you to manipulate the message before it goes to the console. You can read the stack trace in this way. So in this case, the exception was thrown for our file not found. So you know that the file that we were trying to read was not found. Unhandled exception of, file not found. That's a more detailed. And then could not find the file name, text, etc. So then I could go to my C drive. I could find what subfolder I'm looking at and see if that file does exist or it doesn't. If it does exist, it might be a permissions issue, in which case it should be a different exception that's thrown, but I've noticed that some of the exceptions don't always match what you are supposed to be looking for. So that is a semantic error. A semantic error is one that is not syntactically wrong, but has an unexpected value at runtime. And it's also how most exceptions come through, not handled. There is actually one more really useful aspect of breakpoints called a stack trace window. And we'll see if I can find the dang thing. It would be call stack. I think that's under a different view. Perfect time to teach you about the search feature. This is Control Q. I will not put it above my webcam because it's right there. It says Control Q. But I want to see my stack trace or my call stack. Control DC. I'll click that, and I'm going to pop it right into my error pane there. And you can see that my current line where my breakpoint is and where my current cursor is, the yellow arrow on the red circle. I'm currently on first application exe, output values, etc. You can obviously double click that and see where it's come from. Program.cs is something that's generated automatically when you create a Windows Forms project in Visual Studio. And you can jump between the lines on that call stack. So if I were to step over, right, because I have a semantic error there. If I were to step over, you would be able to see where my cursor goes contextually. So notice it doesn't put a bunch of stuff out on while. It does change my line number, but the call stack is purely for when you call a method or function. Where are we at? 9. Okay. So now we're back. Notice that it breaks again. It breaks again because I hit F10 at a place where it was requiring user interaction. You hit F10 when a user is supposed to be putting a value in. It will pop up the window to allow the user to type in or enter in their values or interact with the system in some way, shape, or form. And then as soon as they make some sort of interaction that you want to handle, in this case, closing the form, Visual Studio looks at that and says, oh, hey, they still want to keep debugging afterwards. So now users have input value or interacted with the system. Let's show what happens after that. In this case, I closed the form, and Visual Studio's form1.designer.cs automatically comes through and says, hey, that form is going to be disposed, which means it's going to go away from memory, and we're going to handle that. You can also see this really handy Diagnostic Tools. This is a more advanced pane. This is for performance monitoring. It will tell you briefly how long it took to, or how long it has taken to do the operation, in this case based.disposing. And it will show you your current memory usage, your CPU usage, and all that. I don't use this pane a whole lot because I don't do a ton of performance stuff at my current position. But when I was in the manufacturing, the plastics injection molding industry, I used this pane quite a bit because we were working with sensors and I/O systems that were very time sensitive and very memory sensitive. So that can be useful if you're in a job that requires you to pay attention to that. You can also point out Stack Overflow issues, which is, once again, a lovely segue into our website. There are a couple of websites out there that I really pay attention to. This is the first one. Stack Overflow is universally known as one of the most used, helpful, and community-driven websites for finding errors and solutions for code snippets, for semantic errors, and so on and so forth. It's a great collaborative tool to help you with pretty much anything you could think of. Stack Overflow is really general though, so it doesn't necessarily just understand what language you're working in. So think of it like Google, but for code. So in this case, you want to make sure you enter in what language you are having an issue with. You can search your exceptions, and when you hit enter on that, you can actually go through, and there are going to be a bunch of pages of this. But you can, just like in Reddit, you can find what people's issues are. In this case, change a picture box image with a C#, file not found exception. You read the original post, you can see the tags. Make sure if you're coming into this website from Google, for instance, file not found exception, you can see your Stack Overflow site. Oh, hey, this is C#, cool. But if I just do file not found exception, Java pops up. Yep, a lot of Java. That one's Microsoft, so that'll probably be C# related. Lot of different languages out there. But if I say on Stack Overflow, you might just see file not found exception and scroll through and be like, why is this code not working in mine? Why can't I adapt it? Make sure you're checking your tags, which are found just below the original post. The green check mark means this has been a viable answer for the original poster, and it will show a lot of times you'll find people entering in really long explanations for things, especially for much more complex issues. You can enter in code snippets. You can post links to JS fiddles or other sources. The more citing or citations you do, the better off you're going to be. It is a community-based and it is a honor-based system, as well as an upvote-based system. So you can upvote answers. It's highly recommended that you do upvote answers that are useful. It gives people honor or badges and some medals to be kind of a champion on the website and give them a little bit more reliability when they answer questions. Treat it a lot like Reddit. Use it as a professional source to be kind of a voice in the community that says, hey, I want to further my understanding, and make sure that you're giving back by answering questions for people that might have questions that you can answer. Make sure you're not just leeching information, but you're giving information as best you can. It's free to sign up. I'm not sponsored by Stack Overflow by any stretch, but I use them on a daily basis, maybe dozens of times, because I run into a lot of exceptions that are just weird, out of left field, awkward questions. Where are we at? This is a long video, and I apologize, but this is stuff you need to know. I say that in every episode because I'm way too talkative, but in this case, sorry, you're gonna have to deal. So the next resource you're gonna look for are tutorial websites, because they will show you the basics of how to do things that you're not familiar with. .NET Pearls is a great one. I'm not a huge fan of the layout of the website, but you can click on and find, actually it's because I have dark read. Oh no, I don't. Okay, whatever. I can go through and find what these arrays and different topics are, how to implement those functions and features in C#, and get a general feel for it. If for some reason that doesn't work in my code, there's probably an applicability problem with my code, a semantic or syntactical issue in my code, and then I would go to Stack Overflow to see why that might be happening. Feel free to browse Stack Overflow as well to see what errors are out there that are relevant or related to yours. Generally the mods don't like it when you double post on something. So if you find a file not found exception, it's probably been covered 100,000 times. If you have something a little bit more specific, like code returned from Arduino 068227 or whatever, that's a number I just pulled out of thin air. That particular error might be very specific to a condition that other people haven't run into. Might be memory failure or something like that. That's fine to post on there. Stack Overflow also has a bunch of sister websites for network administration, business preparation, accounting, things like that. It's not just Stack Overflow. There are a bunch of Stack Exchange websites. And you can go to stackexchange.com and find all of their websites that they support. And there's a lot of them. Anyway, so that covers websites. We've covered semantic and syntax errors. I actually do have a breakdown or an outline of what I wanted to cover, and I've stuck to it fairly well. But complex topics, right? There are a couple of other Visual Studio windows that are very useful, or features that are very useful to know. Sorry, I'm very sneezy today. The weather is finally turning nice from the winter. So the two that I'm going to talk about are go to definition and find all references. Go to definition essentially says that if I have a method, I wonder if I can just Control Z. You can hit and hold Control Z to go back in your code, by the way. Yes, sweet. So go to definition. Say this is out of sight, out of mind. Ignore my abysmal white space there. I'm trying to prove a point. That should be where you can, on your definition, you can right click and go to find all references, Control KR, and find all references will show you everywhere in your application, across every class, across every UI, across every place that it's called, and it will list them out. In the code base I have at work, I did this for one function for calculating a dollar amount, and I had 146 individual calls across 90 classes, something along those lines. So this is incredibly useful, and you can, if you have this in another pane, you can double click on the top part and that will take you to the declaration, and you can click on the sub area and that will take you to, or the sub item, and that will take you to the actual call. Incredibly useful. You can also close these tabs by right clicking on the title of the tab and hitting close, or you can close or you can auto hide and things like that. You can also pin them so that it expands your code area. Actually, another useful thing for you to know is you can pop these out. I think I covered this before in episode 1, but I know a guy that I worked with very briefly that did not know that you could do that. So he was doing all of this on one screen like I am right now, and that's fine, except it can get really cumbersome. If you have multiple screens, feel free to pop the panes out. They're configurable. So, for instance, one of my favorite ways to play is I pop all of my utilities like this out, and I snap my Solution Explorer to the right, resize, and then I have my output there, and I usually, my error list will go above my console, actually. So this is what my side window is usually, and it's usually on the right-hand monitor, and my primary code is on my left. I flip them from time to time. It depends on how much pain my neck is in from doing this or this all the time. So feel free to pop these out, and then you can grab the top title. I did not want to do it that way. Feel free to pull that top bar out. That's getting annoying. I'm going to move it over to my other screen real quick. Output goes here, right? Yeah. So if I wanted to put this off to the side, you can certainly redock this on the side or place it wherever you would like. Because my recording setup is not readily conducive to handling multi-monitor at the moment, I'm losing my train of thought really quickly because it's boring. Pane popping and pane arrangement is just boring. It's really useful, but it's not something that talking about jazzes me up. Anyway, so let's find all references and go to definition. Let's wrap that part up, because I've been recording for over an hour now. Let's talk about locals. Not like tourism, but let's talk about local values, which is arguably another pane. It's not arguable. It is another pane. When we start our program and we hit our breakpoint, you can hit output values, view, and I always have a hard time finding this one. Other windows. When you can't find a pane, debug Windows locals. If you can't find a pane or a window that you're looking for, always Control Q. Always go to the search bar at the top. This is in Visual Studio 2019. That search bar is in the title bar up top. In 2017 and earlier, it's like off to the side where this live share button is or whatever. From here, you can see your contextual values. So you can see this. This is the global variable that refers to the current context class. So in this case, it's first application.form1. If I was in program, it would change, or if I had my cursor in program where my debugger is currently at, this would say first application.program.cs. This also will tell you what the text or the title of your class is currently, if there is one. You can see sender. Sender is the button that triggered this particular event. E is an implicit exception, which is actually these event args here. I guess it's not an exception. I use E for exceptions a lot. In this case, event args that are passed in. And, oh yeah, I is a global variable. So it will be in list. You can scroll down or you can search. And in this particular case, it's not overly useful, but you can find your I variable somewhere in here, I think. May not be in this, actually. You can also right click and add a watch. So if you're waiting for a value to hit a certain number, say you're iterating through a list of items and there's an exception being thrown on item number 12, you can put a breakpoint in and you can jump through your lines. Or if you do a breakpoint like in your while and you don't want to step through everything, you only want to read and take the time to really analyze your loop when I is equal to 12, or in this case, say 5. Throw your watch pane here, and then you can just mash F5 until I'm not iterating. See, semantic error. And sometimes Visual Studio will let you update values, or update the value of a variable in the middle of debugging so that you can test specific cases. In this case, when I change I, it does change the value in your watch, but I can mash and then say at value 8, I want to actually step through. I can actually view what that value is. A lot that we're covering in this particular episode. So I'm going to finish up with mentality. And because this is not a technical aspect, we're going to skip over to this particular shot. Mentality in debugging is a difficult one to nail down because it takes a specific thought process to successfully reverse engineer user and personal actions backward towards your code base. You have to think situational context or situational reproducibility or reproduction, and you have to think of where that works in your code. And if you don't know your code base, that can be a very, very difficult thing to nail down, especially if you don't know your code base. My recommendation is to always start with what the user or the system is doing at a given time. In this case, if we are running our program and we have an exception coming in or a problem happening when we click a button and we get this error or the app crashes, user says, hey, I went to calculate a new sale amount with discounts applied. I put in 10% discount and then I hit apply discount and it crashed the application. Well, you know that the user has entered in a specific discount and you know that they clicked a button and it happened, it didn't crash until they clicked a button. So you find that button in the program and you find where the event or where the click event is being handled, and then you can step through your program there. And when you're debugging, F11 is a huge help, because if you have a bunch of methods in your event handler that are being triggered or nested and triggered that way, you can follow through where the value is breaking every time. And it's almost always some sort of type casting or some sort of misinterpreted value or a failure to get a specific value. That's where I start looking for problems pretty much everywhere, because that's, especially in app support or in a production environment, that is more often than not where errors are going to be filed from. It's going to be from the everyday user that uses the application in a way that you did not necessarily intend, or the programmers and engineers did not necessarily intend for. And it happens everywhere. I mean, every application has unintended uses. You can probably find a way to break Microsoft Excel more ways than actually use Microsoft Excel, although Excel is a pretty robust program now that I think about it. The difference between debugging in WPF and Windows Forms is not massively different, but when you get into WPF, you see data binding and event binding a lot more frequently than you do in Windows Forms. Windows Forms does have data binding and it's used prolifically, but WPF took the mentality of web development's model view controller architecture, which we can get into architecture way down the line. But MVC is model view controller, and WPF implemented this MVVM, model view model, that mimics that architecture pretty heavily, and it requires data binding, which I love data binding, I really do, but it can be complex and difficult to debug because there are very few places where you can interpret, unless you know the code base like the back of your hand, where the entry point is from the user back into the code base itself. That can be really complicated or nearly impossible if the generic data types are being used. And we'll get into generics when we get into, more than likely, when we get into complex variables and things like that. Debugging is a mentality and a skill that can carry across between any language that you use. Python, Java, C#, C++, C, COBOL, assembly, just to name a few. If you have the mentality of reverse engineering from any start point, it becomes much easier to be able to determine what a program is intending to do versus what a program actually does. And a good debugger, a good engineer that can reverse engineer based on bugs, invaluable. And you'll get a job if you can prove to an employer that you have incredible debugging and reverse engineering skills. You'll get a job in software engineering. That is, by and large, one of the biggest and most sought skill sets in software engineering. Highly important. And this is just a basic overview. And I know I've prattled on for an hour and 15 minutes or so for my recording, which means that this video will probably be an hour long. I apologize. But this is a complex topic, and it evolves the more you get into software engineering and the profession as it is. This particular program, or this particular aspect of the programming world, is complex and builds on itself so often. It's so specific to your code base. You will have to work this skill, just like a master luthier does building guitars, just like a master blacksmith, just like a master welder, or any of those trades and any of those skills. You have to hone your mind, because there's not a specific tool that is going to make life so completely easy and simple for debugging, because it's not possible. It's all trying to interpret how a program has been made and how it's being interacted with, and no computer on a regular market can do that, as I understand. This has been a lot of information and a lot of me talking, and long video, little bit of a mind bender here and there. The basics almost always are, especially if you've never been a software engineer before or had any exposure to software engineering. If you're not a software engineer, fantastic, great. This is an episode for new developers, new engineers, new architects, managers, business owners, people that are actually, or managers of offshore or outsourced businesses for software engineering, this is important. Knowing and understanding the complexity behind debugging an issue. When you file a ticket about a feature or a part of the program that is broken, it's really important and really, really great if you know how debugging works and what goes into it. This is a really, really, really simple breakdown of debugging. But when you get into complex programs like the crit program that I showed in my second episode, it becomes exponentially more complex to debug issues, because debugging is not a one-to-one. You don't write a line of code and say, oh, hey, now, it took me 20 minutes to make this section of code. It's going to take me 20 minutes to debug it. No. More often than not, it takes like 20 minutes to write a block or a contextual block of code. And it takes you, if you have an error with it, depending on the error, it could be anywhere between 2 minutes if it's a syntax error, all the way up to, 6 days for semantic errors. I did, as a quick example, at my job, I was implementing a feature which was just adding a pick list value or a combo box or a drop-down menu item to a user interface. And I wasn't even adding the list, I was adding one item to the list, and I had to get it to sync from a web interface to a desktop interface via a database and an API go-between called MuleSoft. MuleSoft is a great technology. I'm not going to get into that, and not a sponsor. But the go-between there at first seemed like it would only take me a few days to get all three of those systems to work together and to handshake. I just wrapped up the actual code for it about a week ago, and that put me at a solid 8 or 9 weeks, 7 or 8 weeks of work, and that was like daily probably put in about 6 hours on just that, for a grand total of probably 4 weeks of development time, because I had 2 weeks of training in between there. Anyway, all that to say that something that looks super simple, or something that is just a button click, or something that is just this, or could be described as, well, it's really simple, it's only this, more often than not in debugging takes 2 to 3 times longer than you would anticipate. And you'll get, if you do Agile and Scrum or Kata or whatever, this iterative development process known as Agile or some permutation of it, it requires you to estimate the amount of time that you're going to spend on a job. And not necessarily via job time, but through complexity and how much effort it's going to take you as an engineer to get into. That was a big fear for me getting into the industry, was I don't know how to estimate my time because I've never had to track it. It takes practice, it takes time, and it takes focus. I recommend bringing up a timer and maybe having a spreadsheet, or using a service like Toggle, or something like that, where you can track a task, a project, a client, whatever, and it will tell you granularly how much time you are spending on a specific project. And don't be afraid of any time. If you think it's going to take you 20 minutes and it takes you 6 hours, that is a metric you need to know. Not because you're a poor developer, but because it will make you a better developer. There's a lot of information that I've gone over, and I said that just a few minutes ago. I know I tend to rabbit hole, and I'm so excited that we're finally getting through the real basics of development. Next episode is going to be error handling and how to grab exceptions so it doesn't break our program. And I think the next episode after that, we're probably going to jump into complex variables, creating variables, creating interfaces, inheritance, etc. I think we're going to get into making our own objects and classes in the episode after the next one. I'm really excited. I'm really, really excited. And I can't wait for you to get this in and really ruminate on it, really focus and learn it and get it internalized. And it will take practice. But I can't wait for you to get there, because when you have that aha click moment, suddenly programming is not just typing a bunch of words on a computer to make something do something. It is now an endless series of possibilities for you to be able to create. And it's so invigorating to be able to say, hey, I need this tool, or I really want this thing, but it doesn't exist. Or I would have to, spend hundreds of dollars, if not thousands of dollars, if not millions of dollars. I could just take my time and make my own. And that's really cool. I love that. If you have questions, if you have concerns, if you have needs for a specific job or what have you, relevant to what I've been talking about in the video, feel free to timestamp this. You can right click on the video and copy video at current time, put that in your comment, and then ask a question, and I will try to address it. I do read the comments, I do follow up, and I do try to offer some advice. And if I think that it's going to be complex enough where it's hard to text or message rather through the comment section, I'll make a video about it. If you want to support me further, that's the best way to do it. To go through and comment. And you hear about YouTube videos doing the like, comment, subscribe thing. I'm not doing these videos for that. I'm doing these videos because I have knowledge that I want to share. And I think that there's a need for videos that go through the process of development in an industry manner. Support me by watching, but you don't have to like, comment, or subscribe. That's not my go-to here. My go-to here is just to share information. And if you like it, awesome. Do what you will with that. Long video and a lot of editing ahead. So thanks so much, and until next time, take it easy.